All right, let's do this. Hello, everyone. Thank you all for joining. It's time for another exciting lightning talk. I'm Parag Katkar, your host for tonight. I'm the head of consulting practices at InRhythm, and we have a lot of exciting content lined up for you. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants speaks on some of the latest trends in the industry. So this week, Andrew Balmer, who is lead iOS engineer with us, is giving a talk on Core ML, which is a library for machine learning. And I'm really looking forward to this talk. So without further ado, let's get it started, Andrew.
Thank you, Parag. My name is Andrew Balmer. I'm an iOS developer at InRhythm. And I'm going to talk about Core ML today. So there's been a lot of talk lately, of course, about artificial intelligence. Now, I'm not going to be showing you how to create your own ChatGPT model, but I will be showing you a little bit about some of the tools that Apple has provided to introduce some machine learning into your iOS apps. So this talk will cover how to create two different models, two different types of machine learning models using the Create ML tool from Apple. So anyone who has downloaded a recent version of Xcode to their computer already has the Create ML app installed on their machine. It comes as part of the Xcode package. And so I'll be showing you how to create a text classification model and then an object detection model using the Create ML app. So I've already downloaded this dataset and I've used a Python script to split the data into a test dataset and a validation dataset. And opening up the dataset, we can see that it's formatted in a way that Create ML understands. So Create ML wants to have a label column and it wants to have a text column. The label column is the category of the tweet or of the text. So that can be neutral, positive, or negative. And the text column is the actual body of the text. And I also have a folder where I've extracted some of the body of the text and dropped it into the different categories that those text strings belong to. Now back in Create ML, I'll create a new text classification model. I'll name it Airline Sentiment Classifier. And here I can drop in all of my data. So I'll pull up that data. I can drop the train CSV, the validation CSV, and the test files with the directories. And I can choose a different algorithm. So I have 3 different algorithms to choose from. And then I click train. So instead of waiting for this model to complete training during this presentation, I'll pull up some models that I've already trained. So I have 3 different models using different algorithms. This is transfer learning. This one is maximum entropy. And this one is conditional random field. And all 3 of these algorithms or these models have different training and validation and testing accuracies. And this one, I had an issue with the testing data, but that's okay because I can work around that. And so now let's test out these models on some actual live tweets. So let's test out our models on some actual tweets. So earlier today, I looked for tweets at United, found this one from just earlier this afternoon. And the user is thanking United for helping to return that user's backpack. So obviously a positive tweet. So let's paste it into our first model. And it predicts with 53% confidence that it is a positive tweet. So pretty good, although not quite the confidence we might hope for. The second model predicts with 97% confidence that it is a positive tweet, so that's pretty good. And the third model predicts with 75% confidence that it is a negative tweet, so not very good. Now, interestingly, if we delete some of this text here, it will predict with 100% confidence that it is a positive tweet. So there's probably something with the word feedback that typically gets associated with a negative tweet. So that tells us we might want to refine our data set a little bit and try and account for maybe some different variations in sentiment around the word feedback. So now that we've tested out a positive tweet, let's try a negative one. And this one, the user is complaining that United didn't have the food that the user pre-ordered 4 days in advance. So let's paste it into the third model. And it says it's a neutral tweet, so that's not quite accurate. It should be negative. Second model, 94% confidence says it's negative, and the first model says it's negative with 51% confidence. So for the second time, the second model is the best one here. And so given that the second model is the best one, we can go to output and we can export our model. And with that exported model, we'll be able to use it in Xcode. Okay, so then the next model that I'm going to demonstrate is the object detection model. So this model allows us to identify objects within images. So if I've got an image of let's say a bunch of different types of fruits, and I've got broccoli well, that's not a fruit, but I've got produce. So I've got broccoli and I've got peppers and I've got tomatoes in an image. Then an object detection model can help me to identify all of the different produce objects that are within that image, and then show a bounding box around each of those items. So for the purpose of this presentation, I've decided to use some images of vehicles, so that I can find the bounding box around those vehicles and classify the type of vehicle. So I've downloaded the data set and it's split into test, train, and validation data. So within each of these folders are the actual raw images. And then there are the annotations for those images. So the annotations are formatted in a JSON format that CreateML understands. It has the label of each particular image and the coordinates of the bounding box for the items, for the vehicles that are within those images. So let's go to CreateML, and I'll create a new object detection model, call it vehicle detector model. And then I can go to my data and I can drop in my training data, my validation data, and my test data. And I can choose an algorithm to use. So I might want to try both of these to see which one gives me a better result with a smaller file size. And then I'll click create, and I'll start the training. So that training might, because it's dealing with a lot of images, might take a long time. So I'll show you a completed model that I completed earlier. And so looking at the accuracy, it's not great with this model. So 50% accuracy on the validation data, 33% accuracy on the testing data. So I might need to play around a little bit with different parameters for the training data or different algorithms. It's also a kind of a small data set. It's 600 some images. So I probably want to have more images than that in order to create a more robust data set with better results. But this is a start, I guess. So I can drop in some test data, some test images. Oops, sorry, 1 second. I think skipped ahead of myself there. Okay, so okay, so I've got some test images containing different types of vehicles. So dropping in a car shows the bounding box of a car. Dropping in a motorcycle, that successfully shows the bounding box of a motorcycle. Let's try a truck. And again, it succeeded there. Also shows the bounding boxes of 2 other vehicles in the background. And we'll try an ambulance. And again, looks like we got an ambulance here, although the confidence is, well, let's see, the first, so that it identified 2 objects. The first is an ambulance with 100% confidence, so that's good. It also identified a second vehicle at the bottom here, and it says it's a bus with 55% confidence. So not great, but the first one is the result that we want. And so now let us output this model. And now that we've outputted the model, we can drop it into Xcode. So I've already dropped in my vehicle detector model in Xcode. And if I go to my view controller, show you just kind of the basic setup for what we're doing here to create a very simple app. So I need to import the vision framework. And then when the view appears, I want to start a capture session with the camera so I can record a live video feed with the camera. Then I need to initialize the model. So I will initialize the vehicle detector model. And then using that vehicle detector model, I'll initialize a Vision Core ML model. And then I will create a Vision Core ML request using that model, using the vision model, and then using the completion handler that I'm specify below. And so that completion handler will take the prediction that the VN Core ML request has predicted. So we can take the first prediction that the vision framework has output. And then using that prediction, we will draw a bounding box around the object that was identified. And I will run the app and show you what that looks like. So I recorded this live with my iPhone, and this is showing the live video stream and identifying the vehicles that are shown in those images. So it's a pretty good outcome. So mostly identifies the motorcycle successfully. The car, it's identifying really well. The ambulance is not so great here. Sometimes it thinks it's a car. Sometimes it thinks it's an ambulance. And the truck is pretty good as well. So there's a lot of refinement that we could do. So like I said earlier, we probably want to use a bigger data set for training those vehicle images. And we might want to experiment with different frameworks, or sorry, different algorithms for those models. But this is a start, and there's a lot more that we can do with CoreML, and I'm excited to see where CoreML goes in the future. Thank you.
Hey, Andrew, so what got you interested in playing with the machine learning, and in particular the Core ML?
Sure. So I think it was introduced. I think Core ML, the framework, was introduced in 2018-ish. And so it was pretty exciting when that came out, and I was definitely interested to see what was what was possible with that. And I really liked that Apple kind of provided some tools to make it easy to experiment with it. So that CreateML app, a lot of machine learning stuff is you can get really in the weeds with it. And there are people doing really amazing things with it, like ChatGPT. Yeah, you can get really in the weeds with it, but I liked that Apple provided some tools to kind of get people started quickly. And I thought that was a nice opportunity for me to experiment and see what was possible. And um, adding ML models into iPhone apps can be really useful for all kinds of developers, even developers who don't have a lot of experience with like the really kind of heavy computer sciencey algorithm work. So the fact that Apple makes it easy to get started, I think, is a real benefit to the iOS app ecosystem.
Yeah, this is pretty cool, Andrew. One question I have is, is it gonna take a lot of memory, right? If I integrate this into an application, and we set a lot of images and all that, is that gonna bump up the app size, or?
So it depends a lot. So the first model that I showed you was the text classification model, and that's very small. I think the model was like 4 or 5 megabytes. So that's not a big deal at all. The image classification models vary widely. So I've seen some image classification models that are several hundred megabytes, but I've seen others that are like 20 or 30 megabytes. And so it depends a lot on the particular model. It also depends on the particular algorithm that you use. So some algorithms are really efficient at creating a small file size. Sometimes that small file size comes at a trade-off to accuracy. So it just depends a lot. And there's lots of information out there about those trade-offs and like which algorithms you might want to use for certain situations. But it is not a given that including a vision model in your app will explode the file size. You can definitely find a small vision model and still have a pretty reasonable app size.
Okay. Yep.
Andrew, I have 2 questions. So on the video you showed where your model was struggling to recognize ambulance or car, right? How to make it more accurate by just providing more data?
Yeah, I would say the first step is more data. So let me show you the data set in a second. So okay, so well, first of all, to address the earlier question, okay, so the vehicle detector model is 7.1 megabytes, so that's really small. Now, it's, as we discussed, it's not the most accurate model, or it had some difficulties with accuracy, but it is a really small model. So that's pretty nice.
Okay, cool.
Now, let's see, let's look at some of the training data. So training, well, I can't. Sorry, I was going to show you like some of the photos of ambulances, but I think some of the photos of ambulances, there are 600 images in this entire data set. I think there are maybe like fewer than 100 ambulance images, and that's just not enough to create a really robust model. I mean, if you think about all the different like angles that you can capture of an ambulance and all the different colors and settings and cropping situations and all that of an ambulance, 100 images is just not enough to create a really robust data set. Now, another thing that we can do though in training is we can excuse me, we can augment our existing data set. So let's create a different model here. And oh, you know what? I can't do that with the object detector model. But what I could do, so with a different model with image classification. So this is image classification is similar to text classification. It will take an image and will classify what that image, the subject of that image. So you know, it might take images of different types of animals, and it'll say whether it's a dog or a cat or a horse. So that's useful for when the image has only one type of animal in it. Object detection would actually draw the bounding box around those animals. But for image classification, let's just create a sample project in CreateML. So I can drop in the training data, but I can add these augmentations. So I can, so let's say I have one image of a dog, but then I add all these different augmentations, which will basically create variations of that one image to augment my data set, so that I have a more robust data set that will create a more robust model. So that's a nice tool that CreateML just has built in, and that will help us to create more robust models.
That's really cool. Yeah, thanks, Andrew. Thank you on this.
Oh, sorry.
I just wanted to ask my last question.
Okay.
So this CoreML and Vision Frameworks, they've been around for like 5 years already, right? How widespread they are currently? Do you know some examples?
Yeah, that's hard to say. I mean, you know, I personally, in my professional career as a developer, I have not had a chance to use ML models in any of my apps. So, but you know, that my sample size of one here. I'm not sure. Yeah, I'm not sure. I guess I would say, like, you know, if you look at the apps on your phone, you know, there are probably some apps out there that are using some kind of core ML models on them. You know, certainly stuff like Snapchat and you know, maybe Instagram. I'm not really sure. I'm not sure what models they use, and they might not be using core ML. They might be using their own proprietary models. So it's hard for me to say how widespread it is.
Yeah, that's fine. I'll just do research. Yeah, thanks a lot.
Thank you, Andrew, for nice presentation. So cool. I have a question. When you upload this big set of data, what is where do you store this data? Is it local storage or in cloud? Is it safe? For example, if potentially we upload some sensitive data, is it secure when you upload this data?
Obviously the data that I showed you is not sensitive data. It's, you know, it's public tweets and just
yeah is understand.
Now you can let's see, you can encrypt a core ML model. So let's see, I can pull this up. Okay, so oh, and by the way, another kind of helpful tool is when I've dropped my model into Xcode, I can actually preview the model right in Xcode. So I can here and drop in my ambulance image, and then this works. Yeah, so that will show me the prediction right here directly in Xcode. That's just a very helpful tool. Another way that Apple makes it really easy to work with core ML. So just kind of a nice thing here. But you can encrypt a core ML model here. So in the utilities tab, you can encrypt it. So that can help to secure personalized data.
Okay, thank you.
Greg, you have a question?
I did, but Andrew answered it. So I was going to ask how, the machine learning algorithm handled variations on existing images, whether it was a little rotated, a little scanted, a little low light, highlight, exposure stuff, but he showed how he could add those variations already in the model. Because that's one thing that I have totally seen where, if my dog is looking at me, the ML knows it's a dog. But if I get a weird angle from the back or the light shining on her, or it's a little dark, like he can't figure it out. So those augmentations there seem very powerful.
Yeah, it's definitely helpful. That's we can only do that for the image classifier. We can't do it for the object detector, which kind of makes sense because the data has to include the bounding boxes of the objects within the data set images. And so if we're rotating, skewing, cropping those images to create variations, then that bounding box data will not be accurate anymore.
So someone from LinkedIn was asking, how long did it take you to train your model?
So the text detection models, I trained 3 different ones using different algorithms. One of them took like 20 seconds. The other one, I think the longest of the 3 only took like 2 minutes or something. So text is pretty quick. And that was training on, I think it was like a little over 10,000 tweets. So not a huge data set, but 10,000 tweets is not nothing. The image data sets, I think the longest vehicle detector algorithm took maybe like 45 minutes or something. So not too long. I was also experimenting with the object detector, and that one, let's see, I trained an object detector on about 20,000 images, and that one took about 2 hours.
Cool.
Hey, Andrew, question. What if you put an image which is neither a vehicle or an ambulance or a car? Does it try to find the best fit, or does it say that it's none of the above?
It tries to find the best fit. So I was, when I was experimenting with it, at a certain point, I just put my phone down on my desk. So the camera, it was literally just black. The camera saw nothing. And it was still like identifying it as a car. Now the confidence for that prediction was very, very low. And that's how we can, so the vision framework will output, in addition to outputting the bounding boxes of the predictions and the category of the predictions, it also outputs a confidence level of the predictions. So if the confidence, so we can use that confidence to filter out false positives. So we can, if the confidence is less than 30% or something, or less than whatever we set it to, we set it to less than a certain threshold, then we can just not predict something, or say like no vehicles found. So that's something we can address in code.
Thanks. And I'm assuming with more training, more data sets, this confidence will start going towards 0, right? I mean, it'll just say that it's nothing right now. It's can't find any match.
Yep.
Right. Thanks.
Andrew, so where did you get your data sets at? Like, and how long did that take you to put together?
So there's a website called Kaggle, Kaggle. That's a website that hosts a lot of data sets for machine learning, and kind of like challenges for, community challenges for people to work with machine learning models. So Kaggle is a good resource. Let's see what else. the others, I just Googled, machine learning data sets, and you'll find some results of just kind of really helpful sample data sets for anyone to download, and a lot of them are well labeled so that you can just kind of drop them right into your to create ML. One of the issues with machine learning is and creating your own machine learning data set is that can be very labor intensive. So for example, those vehicles and all those bounding boxes, it's, if you're going to label, put bounding boxes around tens of thousands of images and then label their category, obviously that's going to take a very long time. So fortunately, there are plenty of data sets out there of vehicles, so I didn't have to look too hard, and it was already well labeled, and it was already formatted in the create ML format that I needed. But if you're creating your own like very custom model and you can't find a good data set out there, then it can be pretty labor intensive to try and clean up the data and format it in a way that you need.
Great talk, Andrew. Really, really nicely done. Any other questions, guys? All right, let's wrap this up then. As a reminder to you all, we do these talks every Thursday, 5:15 p.m. Eastern time. And next week, I'm super excited. Satish Yadav, who is a experienced Android engineer, is going to give an overview of Kotlin multi-platform mobile, which is also known as KMM. And I'm really curious to hear about the benefits, the drawbacks, the best practices on building the cross-platform mobile apps with KMM. So please mark your calendar for next week. Thank you all once again for joining. Have a wonderful evening, and I'll see you all next week.